Hi everybody. Today we talk a little bit about the Maintainability Index. My name is David. I'm from Runnesroot, an e-commerce, remote-first e-commerce agency based in Germany. And we are very proud we have 0 project managers, although we are a bunch of 15 developers right now. How do we measure software? In the last 2 days, we learned a lot about software quality, to be honest. We heard about new skills, new tools, new methods, new procedures, everything to be a better software developer and everything to make more quality software. But we haven't talked about how we measure that quality. And to be honest, it's not really possible. Software quality is such a big elephant. It's not that you can say, we can measure it somehow. What is your software quality? It's a 5, it's a 100, it's not possible. So what do we gonna do with this big elephant, software quality? It's the same thing we always do. If something's too big, we chunk it down, we slice it up, we call it whatever you like, but we make it smaller. There are a couple of very clever people, scientific people, that did exactly that. They sliced it up and they made 6 different subcategories out of this term software quality. So what we have now is we have functionality, reliability, usability, we have efficiency, of course we have the maintainability, but we also have the portability. As we only have a couple of minutes, we'll focus on the maintainability aspect of it. And we can only touch a single KPI in that subcategory, which is the Maintainability Index. The Maintainability Index, or in short DMI, determines how maintainable your source code is. It's not about your project itself, like it doesn't touch your infrastructure, for example, or evaluates your business logic. It's all about your source code. And the MI is a calculated KPI. And to calculate it, you need 2 more KPIs, the complexity and the volume. To be precise, we need the cyclomatic complexity, which basically is the number of your decisions in your source code. So, for example, an if condition is a decision. And then we also have the volume, or again, to be precise, the health stat volume, which measures the size of your project. It needs like lines of code, but also the number of operators, for example. Now we already have 3 KPIs, and I have to add a little disclaimer here because a single KPI, or even 3, don't give you a lot of value, to be honest, because you always need the context to evaluate the different KPIs. A single KPI doesn't mean anything. You can achieve 100% code coverage, for example, which is perfectly fine, and most of us would say, whoa, that's a good thing. But if you don't have any assertion in that test, then, you know, what value is behind that? You're just running the code. So the real value behind the maintainability index is that you can step out a little bit. You can look from the outside to your project, and if you generate it by class, you can see which class might need a little better touch, which class needs a little bit of love, make it a little bit cleaner here and there, smaller. And yeah, in general, the rule of thumb is the higher your MI is, the better is your code, or the more maintainable is your code. There are tons of tools out there to generate this kind of bubble chart for various languages. And what this bubble chart does is it represents one bubble for every file that you have, or one circle for every file that you have, and it shows you the complexity of each file by its size. The bigger the circle is, the more complex this file. And then you have also different colors of that file, which represents basically how maintainable it is. Red is in a, poorly maintainable. and green is very nicely. So what we actually want is small red bubbles, and we want to focus on the big red ones, to be honest. That's it. Thank you very much.